Okay, number 19b says solve the system of equations using substitution. So when I look here, I have a 2y equals 5x plus 12 and an x plus 3y equals 1. If we're being told to solve by substitution, I want to look for a variable that's isolated. None of these four variables are isolated. The next step would be to look for a variable that has a leading coefficient of 1 or negative 1. This x has a leading coefficient of 1. So I'm going to subtract 3y from both sides. This equation then becomes x equals negative 3y plus 1. I'm going to rewrite my system. The first equation we did not change. The second equation became x equals negative 3y plus 1. So the x now is isolated. Now I could take the negative 3y plus 1 and replace the x in the first equation. This equation will become 2y equals 5 times the quantity, negative 3y plus 1 plus 12. Then I'm going to distribute the 5. 5 times negative 3y is negative 15y. 5 times 1 is 5. Then I'm going to combine these constants. Then I'm going to add 15y to get my variables together on both sides, and we get 17y equals 17. Divide both sides by 17, we get y equals 1. Now to continue solving, I can substitute the 1 into the first equation, the second equation, or even the rewrite of the second equation. I'm actually going to use the rewrite. So I'm going to plug in 1 for y. We get negative 3 plus 1. So we get that x equals negative 2. So our solution is negative 2, 1. Number 20 says use the provided graph to solve the system of equations. So the first equation here is y equals 3x plus 7. My y-intercept is 7. My slope is 3, which means a rise of 3 and a run to the right of 1, or down 3 and to the left 1. So here's our first line. The second line is easier to graph if we have it in slope-intercept form. So what I'm going to do is solve the second equation for y. Then I'm going to graph it in a different color here. So it's y equals 3x plus 5. So I go to 5 on the y-axis, then I'm going to rise 3, up 3, 1, 2, 3, run to the right, 1, up 3 to the right 1, or down 3, and to the left 1, 1, 2, 3, to the left 1. And it looks like these two lines end up being parallel, which is actually true because they have the same slope. So there is no solution. It says explain how you know that the solution, or what the solution or solutions are by looking at the graph. There is no solution to the system of equations because the two lines never intersect. In the next one, it says use the graph provided to solve the systems of equations. So to solve, this first equation is already in slope-intercept form. So I'm going to go to negative 3 on the y-axis for our intercept. The slope is negative 1. So I'm going to rise 1, go up to the left 1. I always like putting as many distinct points as possible in the graph Therefore, I get a really clear point of intersection. Or we could go down one and to the right one. So here's that first line. Again, you don't have to put in all of these points as long as you draw a really straight line. Okay, the next one is also in slope-intercept form. So I'm going to graph a positive 6 on my y-axis. Then I'm going to go down 4 and to the right 1. So my line is here, and our solution is where the two lines intersect. It is right over here at 3, -6. Then it says explain how you know what the solution or solutions are by looking at the graph. 3, -6 is the solution to the system of equations because it is a point where the two lines intersect.